So our next speaker is Oscar Camacho. Oscar, hi, and moderator of this talk, Igor Rubanovich. Igor, hi again.
Hello again, colleagues. Wow, it was very, very interesting, but for today it's not all. And now it's very important and interesting topic. I believe that all of us using these annotations in your code, but somebody don't know how to implement this. And today Oscar going to show us how to implement annotations in the easiest way. It's really not complex. If you don't know, you will see now.
Okay, Oscar, may you share with us some thoughts or some words what your talk would be about and why it's important for everyone to hear that?
Yeah, well, hi everyone. So basically, my talk is about how to implement your own annotations and how to process them. This is like the stepping stone into building your own framework if you are really into that sort of thing. And even actually, we're going to take the focus on how to generate new Java classes based on the annotations that you are actually going to build. So we are going to take a look at a use case and scenario, as a really simple one. And we are going to generate new classes on the fly right now as we go along in the talk.
Great. Just some comments we have here that maybe you may turn your microphone a bit louder if it's possible.
I will try, yeah.
Okay. While we're waiting, I have a question, Igor, maybe to you, just to discuss. So a lot of people who use frameworks like Spring or similar, they say that like they don't like annotations. They say, okay, it's some magic. I don't really understand that. This is something really strange. So what do you think about that? And Oscar, same question to you. What do you think about these thoughts?
For Oscar or for me? Sorry.
For you both.
Okay. Okay, yeah. Just for me, I understand such kind of mindset, because when you debugging something and you see that annotation producing some magic, you will not find what happens inside. So annotation must used with understanding what happens there and implemented for understanding. And sometimes annotation, of course, can cause some performance issues if they will implement it in the wrong way. But of course, all in our hands. We can do bad things and we can do great things. It depends on us. And Oscar, what do you think?
Yeah, I agree almost entirely with you. I mean, if you need to know what happens under the hood in order to actually make good use of your own annotations, all the annotations that the Spring provides. It's not magic. I mean, you just need to browse through the docs a little bit and to actually sit down and comprehend what they are saying. Most of them are going to explain whether or not they generate a new class, or if they are going to analyze it using Reflection API. Something will happen over there, but it's not magic. Basically, you just need to understand what is going to happen, why, and what are the shortcomings of using that type of annotation, and what are the pros of doing that. I think that one of the most, for most of us who use Spring as in a web environment, we can all agree that Spring annotations do make our life easier, in the sense that we need to write much less code as opposed as in the older days. Back when it was only Spring MVC, we had to write like these enormous classes. And right now, I mean, it's just like add rest controller, and you add a simple method, post mapping, for example. And that's it. You don't really have to spend that much time coding anymore. And that's the beauty of using annotations, I think.
Yeah, totally agree with what mentioned. So yeah, guys, let's move to the talk itself. Just a reminder, we have 3 chats basically. The first one chat is on YouTube channel. Second one is in our Discord server. So join there. There are some activities, and also you may find there the chat specially dedicated for this talk. You may leave your questions there. And also we are a community platform where you have agenda and all information about the conference, and they also have a chat. So all 3 chats you may use. We try to monitor all of them, took questions from everywhere. So don't miss a chance to ask your question to our speaker. I became silent. Good luck, Oscar. Good luck, Igor. And Java is on.
Okay. Just give me 1 second. The
Yes,
presentation
sure.
is uploading.
Yeah, so how we see in the comments, annotations are lifesaver. Yeah, sometimes it's yeah, it's totally true that just use one annotation and you will no need to duplicate your code.
Yeah.
Okay,
Totally. So let me just interrupt you a little bit more. Let's start with the actual talk. Sorry for the delay. So basically, well, welcome everyone. My name is Oscar Camacho. I'm a lead software engineer here at EPAM Systems, and I've been actually with EPAM for over 2 years now. And well, basically now we're going to talk about Java annotation processing. And well, the subtitle of this talk is how to create your own annotations and generate code with it. Let's review really quickly the agenda. We're just going to check the theoretical side of things. We're going to review what is an annotation, what is annotation processing, how to create your own annotation, how to process it. Then we will move to reviewing the actual code that processes the annotation. Finally, we will have a Q&A session. So you can follow along once we reach the code part. You can start downloading it or just browsing it. These two links are, well, the QR code and the link will guide you to my GitHub repository in which I have the code. Feel free to fork it, to clone it, do whatever you want. It's a sample repository, so you're free to do whatever you want with that code. Either way, we're going to go around the same slide and the QR code, so you can also access it later. Okay, so have you ever been in this situation in which you work for a project that has like multiple objects with the same behavior, and even though it's a good practice, you start to feel like reusing code becomes a really repetitive task, and you would also like to spend more the time you are using reusing the code itself, doing something more productive, like doing something new, something like that. So we have the solution for those type of situations. Well, actually Java does, and they are Java annotations. An annotation is basically just any code fragment that gives more information about the code that they are annotating. They are identified by using the add character or whatever they call it in your country, and they are mostly used by frameworks or libraries, and they just use it to flag some information or behavior of how to do things. So, for example, right now we are seeing an example of a Spring REST controller, and it's just having a get mapping, and it's precisely what I was talking about earlier. It's really concise, really clean code, and really minimal code, and that's the purpose of using annotations. So what is annotation processing? Annotation processing as a whole is just to extract information from an annotation and use it to your favor. That being said, annotation processing can occur on several parts of the lifecycle of the program. So, for example, as I mentioned before, Spring sometimes relies heavily on using the reflection API to obtain the information from the actual annotation. This type of processing we're going to refer to as runtime processing, which is slow and actually quite compute time intensive. So we are going, for the purpose of this talk, we are going to refer to annotation processing, to the one that occurs at the compilation time. So right here, what we are seeing on our left side of the screen is an example of an actual implementation of how to process an annotation. We're going to review this afterwards, so don't worry. Now let's just review really quickly how to create your own annotation. Basically, you just need to either create your own Java file, preferably, or modify an existing one and add the reserved keyword add interface followed by the name of your desired annotation. And so, as you can see in this example, we just need to we define two attributes for this annotation. These are not mandatory. Annotations can be empty, that in the sense that they can't have any attributes by themselves, or they can also have default values, which we are also going to review later. And yeah, I mean, just to use them, you just need to make a reference to it somewhere in the code. Okay, now let's review how to process our own annotations. Basically, what we have to do is to have ideally you should have a separate project, and more on that later, in which you have all your annotations and the processors of your annotations. That is because you want your annotations to be as independent as possible from the actual code that you're going to annotate with. And for doing a processor, you just need to create a new class that extends from abstract processor, sorry, which is a JavaX a JavaX class, and it's an abstract class, so you need to implement the process method. On that implementation, you must obtain all the information of all the classes or elements that were annotated in your in the code that you are processing. And once you have that, you need to react to that. Either you can do multiple things. Right now, we are going to focus on creating a new Java file, which is like the most standard approach. You can create new Java files, you can create new .classes files, even .properties files, or other type of file, and it's perfectly valid. You can also make several things over there. I probably by now, many of you are wondering about Lombok or similar alternatives. We're going to discuss them a little bit later, and how is it that they actually modify classes for existing classes in order to achieve their goal. So now let's review the benefits of using annotation processing. When we use compile time annotation processing, the generated code can be up to 10 times faster than equivalent code using Java reflections. We're going to have a live demonstration on that. The code that is that you end up with, the actual code base, is going to be easily readable and even reusable across multiple projects. In the sense that, for example, your annotation that you create for one, you can make use of it on another project, and so on and so forth. I mean, we can have an example of a Spring framework. So Spring, it's not like they built their annotations for a single type of project. Actually, they are supporting multiple types of projects, so it doesn't really matter what type of project or what your project is. You can also always make use of the same annotation over and over again. It also enables teams to focus on more complex tasks, also by reducing the time spent in repetitive tasks, and it makes the code significantly more readable. Now let's review really quickly a use case scenario. For this, and just to keep it plain simple, I know that this already exists in Project Lombok, but bear with me. So we are going to make our own builder annotation, and basically what that means is that we, for example, imagine that we are working in a project, and a backend project in which the performance is like a key directive, right? So we have like several entities that have a constructor with multiple parameters, right? So, for example, imagine that each entity is a map one-to-one to a database table in a relational database. So you may end up with, like, I don't know, like 10, 12 parameters in a single constructor just to build a single entity, right? So that's not really readable, and it's actually quite confusing over time, and we want to avoid confusion. And also the team is looking for a more readable way to instantiate these entities. So in the traditional sense, you would make a call to new entity and pass the parameters to the constructor, and whatever objects are not considered in the constructor, you're going to assign later on. And yeah, so that takes up a lot of lines of code, and if the code is not correctly maintained, it can lead to a quickly unreadable code. So we want to avoid that altogether. So we are proposing that we build a builder annotation. By how are we going to go about that? Is by, if we have here a class diagram in which we are going to just review really quickly, like the main players. So we have an abstract processor, which is the class that's exposed by JavaX in order for you to actually build your own implementation of the annotation processor. We also have the abstract annotation processor, which is our own implementation of the abstract processor, just to try to have like a common logic built into it, so that we don't have to worry about how to extract the actual the actual classes that were annotated with our annotation, and just focus on validating them. We're going to transform them, as you can see in the second method, and that's because the information that is provided to abstract processor are JavaX elements. Those instances are quite complex. They don't have like a one-to-one relationship to something that we may know in code. So for example, we know that classes have attributes, classes have setters, getters, and so on, right? That doesn't quite correlate to what JavaX elements are described to be. So in order to reduce that type of complexity, we're going to transform them into a model of our own. Plus, it also helps us with the lifecycle of the element instance itself, as that's managed by the compiler. And we don't really have like a real mechanism to actually create new elements on the fly. So in order to avoid that altogether, we are going to just transform that to a model of our own, which is described in the descriptors package. Again, this will contain, for example, class descriptors, method descriptors, constructor descriptors. The basic things of a class and all its elements are going to be mapped over here in our own model, with things that we know and love and comprehend of the Java programming language. The actual implementation of the annotation processor is going to be handled by the annotation processor that will implement the three abstract methods that we defined previously on abstract annotation processor. And just as a quick note, the finalized element processing will have a direct call to an instance of builder class writer, which is an implementation of Java class writer. That is the class that we created to basically have the logic centralized for writing a new Java class. This particular Java class writer will make use of the filer object, which is exposed by the processing environment by a abstract processor. So we will take a look at that and how is it that the filer object actually allows us to create new classes. Well, new objects and new class files or source property files, whatever. So let's review the code. Let me just now, I'm going to share my screen I'm going to present. Let me change this one. Well, actually, first, let's stop right here for a little bit, just so everyone can get the code if they haven't. Again, both the QR code and the tiny URL are going to direct you to the code on GitHub, and that's like the latest version right now. So feel free to to download it and to do whatever you want with that code. You can use it as a template, whatever. So let me just now share my screen. Igor, can you help me add my screen to the presentation, please?
Hello again. So something freezed. Oscar, can you maybe try to reshare?
Oh, okay, yeah. Let me reshare now.
So colleagues who are watching, looking for watching us now, and if you have some questions, please do not forget to post them into our chats, YouTube or Discord, everywhere. You can ask, because it's rather technical tech talk. So maybe something not clear, you can ask, of course, and we will handle. So I see we are good with screen sharing. Please, Oscar,
Okay.
go ahead.
Thanks, Igor. Okay, we're going to start really quickly with the POM. Since this is a Maven project, you can make use of Gradle if you want. I just find it Maven to be somewhat easier to explain. So as any good old plain POM project, Maven project, sorry, we can have properties. It doesn't really affect the way that we are going to make use of our code itself. However, for this particular code, we are going to make use of this library of exposed by Google, which is auto service, and the scope is quite important to have it as provided. Yeah, the version it keeps updating, so check back with Maven repository to find like the latest one. But overall, this is like the sole dependency that we are going to make use of, and you're going to see exactly where we are going to make use of it. And it's actually just to use another annotation. So don't worry, it doesn't do much other than registering your own processors for the compiler to make use of them. Other than that, you can add as many dependencies as you want. For example, right now we are making use of a unit and JUnit parameters just to make testing a little bit simple. As far as build plugins go, it's not necessary to declare all of them. However, this is, the compiler plugin. It's one that you may find useful to declare it in your own implementation. Right now, we have it set up with the configuration tag to force the Java compiler, and that's so that we can debug properly our processor. Otherwise, Maven will fall back to JDK tools, and it will make use of that compiler or compilers or whatever. But if you force it to use the Java compiler, then whatever error you may have while actually developing your own processor, it will be much easier to track down, as it will provide you with more information of where and exactly why it broke. So that's useful to have. Other than that, the Shortfire plugin is just for the testing part of the project, so don't really worry much about that. So let's dive right into the actual code. Well, I think one of the most interesting classes that we're going to review is the abstract annotation processor. So basically, this processor will use two generic types, well, two type parameters, which is A for annotation. All annotations in Java are extent of this. I guess it's an interface, so you can make that like shortcut to find if the class that you are using as a type parameter is actually an annotation. So that takes some part of the validation out of the way. We are using an M to represent the model itself. And that's just so we can, well, in the process method, as I mentioned, it's the actual method that we need to implement from abstract processor, which will actually do the actual work of getting all the annotated elements. So as you can see over here, we are going to have a for loop in which we we're going to iterate over the elements that are provided by the method round environment, get elements annotated with. The round environment, we have to think of the round environment as a compilation wave, in the sense that let's imagine the code state, right? So we're going to have the initial state, which is the state at which the code started with. So imagine you just did a Maven clean, right? So you just have your own your source files and nothing more. So with that the round environment is going to correspond to that first state of the code. Once the first annotations are processed, they're going to generate new code, right? Or do some side effects. So once that is the first round is finished, you're going to end up with another round that recompiles all the code plus the new files generated. And that is done iteratively until nothing is left to compile. So that's what round environment is, and that's why we are using it to obtain the elements that were annotated. So just for simplicity's sake, we are just obtaining the elements that were annotated with annotation class, well, with our annotation class. Otherwise, it can get a little bit tricky when you're trying to process annotations from a whole package instead of a single class. So just bear that in mind. It's not impossible by any means, but it tends to get a little bit more complex over time to maintain that code and to actually have it on something useful. Now, so every time we are iterating an element that was annotated with our annotation, we are going to have three main methods, which is validate element, which will actually verify if the element that was annotated with our annotation makes good use of the annotation itself. The second one is transform element to model, which is, as we've described earlier, just the part in which the model, well, the JavaX element is going to be translated into a model of our own. For our project in particular, we're going to make use of the descriptor package, and more on that a little bit later. And finalize the element processing, which is the last the last method that we need to implement, which is the one in which you can do whatever you want with whatever element you annotated. So that's like the logic of all of this, all the abstract annotation process or implementation are going to follow. And we also have some quite useful debugging tools, such as print error message. So imagine that you have an error while, well, you encounter a usage of your annotation, so you throw an exception. In this case, for example, we created the bad annotation nudge as exception, and just you throw an exception stating that the user, well, the developer is making bad use of your annotation, and that should be a compile time error. So that's how you're going to print the actual error itself. So let's take a look at the actual implementation of this, which is the Blogger annotation processor. Now, as you may saw, the previous class was an abstract class, And that's because that's going to be like the common logic that all processors should have out of the box. But the actual processor that is going to be called by the compiler, it's going to be this one. So that's why we need to annotate this this class with these three annotations. The first one is supported annotation types. Well, it's not really necessary to annotate that, but to annotate this class with this, but it's like the easiest way. Otherwise, you need to implement the get supported annotation types method. So there's like really no good need to actually do that, and since you're always going to return a constant, so that's why it's useful to use this particular annotation. Over here, well, actually, this annotation will receive a set of, well, at least a collection of strings corresponding to the package, well, to the fully qualified name of the annotation that you're going to support. So in case you do want to support multiple annotations, you can do that. Well, you can define them over here. Right now, we are just going to support only one type of annotation. So there's not really a need to do that. As far as the next one, which is supported source version, this one is quite interesting because you're going to state which version of Java you're targeting your annotation to work on. So obviously it will work upwards to this, but that's like if you ever work with Android, for example, this is like the min SDK attribute, in which that's like the minimum released version that you need to in order to make use of your annotation. So in this case, it's release 8, which is, I think, up until this day, the most common one. So that's I think that will increase the compatibility of your code. Now, this is the actual the annotation that we described earlier by Google Auto Service. So this annotation, what it's going to do is going to register your annotation to the compiler itself, so that it make use of it it registers it, and the compiler knows to make a call to this processor in order to process any code that was annotated with this annotation in particular. So that's quite useful. That it's the only actual external dependency that we're going to use throughout the project. You can make the actual registration yourself, but I just think it's really easier to just make use of the Google dependency on this. So moving forward, as we stated before, the abstract annotation processor, a builder annotation processor is going to extend this abstract annotation processor, and our annotation is going to be the builder annotation. So if we review that really quickly, it's your typical builder annotation. It's quite similar to something like the Lombok one. Maybe the field, the name of the attributes are a bit different, but they are mostly the same. And what I wanted to review over here is actually these two annotations that annotate our annotation. So basically, the annotation it's going to refer to at which point in the code execution lifecycle is going to, the annotation is going to be present. So we have multiple options for this. We have this tree. So source, as it was before, it's going to describe all annotation that should only be present in the actual source and will be deleted after the compilation has finished successfully. Class, on the other hand, does somewhat similar, but it's not deleted after the compilation time. So that's like the main difference over there. There are more, but those are like the main to remember. And runtime, basically the annotation is going to be available once you're even as your code is running. So For example, if you're going to do something such as the reflection API processing, you may want to make use of the runtime retention policy. But for us, since we know that we don't want to process it on the fly, we're just going to make use of source as such. The target, it's actually one of the most useful ones in order to validate your own, to automate as much as possible of the validation of your annotation, but it's not going to be fail-proof. So for example, when we specify the element type to be type, what we are saying is that most classes are going to be able to make use of this builder property annotation. Sorry. However, it does not exclude, for example, abstract classes or final classes. Something else, all the combinations in between. They cannot be they will be considered valid by the compiler, so you still need to validate them afterwards. And that's where the validate element method comes in. Basically, we need to validate for simplicity's sake on this example. We're just going to validate if the annotation is being used in something other than a class, which should never happen since we have the target annotation. This case should never happen, but either way, we are handling it just to be safe. And on the other hand, the other edge case that we are not going to be supporting right now is abstract classes. So for simplicity's sake, we don't want to implement abstract classes. So yeah, that's going to be that. And it's just to demonstrate that we don't want to do it. In this, if you annotate, for example, an attribute or another type of element, you may have all the other parameters to validate whether or not they are using your annotation correctly. So let's move on to transform element to model, which is the actual, let's say, hard work that you actually have to do. So the element interface is going to expose an utility method, which is accept. This what it's going to do, basically, we need to it's going to allow you to obtain all the information regarding an element from let's say in a standardized way. So in order to do so, we have this class named type mapper, and we are extending this class, which is also provided by JavaX, which is element kind visitor. The number is basically for to state the Java release that it's the target of. So, for example, if you were to analyze this code with SonarQube or some similar code analysis tool, you may find that this class is going to throw an error or a smell, saying that it has like too many parents, which is not allowable. But that's okay. Well, I mean, I think it's okay because the way that these classes are designed to behave is that basically the newer version inherits from the previous version, and so on. And so basically, right now we have version 18 of Java, so we now have we have some a pretty extensive list of element kind visitors. So, for example, if you weren't implementing, for example, the 14, you are going to have like I don't know whichever number of versions before 14 was for Java, so of warrants. So that may throw a smell, but it's nothing to worry about. There's nothing you can do about it also. So yeah. Over here, we are going to have the element kind visitor will have several methods in order to actually have to analyze certain elements in a certain specific way. So for example, right now we since the builder annotation will only annotate classes, we're just overriding the visit types class, but we can have several other methods that we can override, such as variables, packages, enums, interfaces, type parameters, exception parameters, the throws clause from of a method. Those are the exception parameters. Modules for certain Java versions. Yeah, I mean, you can name almost every type of element inside any valid Java element is going to be visitable. So you just have to find like the correct combination of element that you want to visit and how to analyze it. So for our sake, we're just going to analyze the class. However, that's easier said than done because, as you know, describing a class is not just getting its name. We also need to have like the setters, the attributes, especially for a use case which is a builder. So for that, we need to also analyze the enclosing elements, which are the elements contained by the same element. And over here, we're going to extract information for constructors, the fields, and methods. And if not, well, we just don't analyze it as a whole. But I mean, you can make this as complex or as simple as you want, depending on your needs. So the type mapper, once it obtains the translation to or to the objects in our descriptor package. So for example, right now we're going to obtain the class descriptor because we are typing classes. It will return that, and afterwards, this is just like utility methods for obtaining a mapping between setters and the actual attributes, which are going to be useful for our builder. And we just return the model that we're going to use, in this case, the builder annotated class, which is a model, well, an object that we created to contain all the information regarding the actual annotation and the class that was annotated. And finally, we get into the interesting and I think the most useful part, which is the finalized element processing, in which we are going to build our actual class. So let's take a look at this method. The general builder class of the builder class writer is just going to make a call to write file of the Java class writer. And over here, it's the actual magic part that we previously described. So it's not actually magic. As you can see over here, we're going to make use of the JavaX filer, and the JavaX filer is going to expose several methods. In particular, for this one, we're going to make use of create source file, but we can also make a create class file or create resource. So whichever one you prefer and whichever one suits your needs better, you can create one over here. And basically over here, and once you created the source file, printing to it, it's just like printing to any other file. So the generated file, which is a Java file object, is going to expose a writer. So you can make use of whatever writer you want, the buffer writer, whatever. The actual implementation doesn't really matter. Right now, we're just making use of print writer because it's quite simple. And we're just going to write the class itself. Our class itself is going to extend from generated class, so that well, in generated class we have our toString method is going to have all the logic necessary to create the actual class. No, so for example, for us it doesn't make sense to have like a private class or a protected class or whatever. So we're just going to default to public class, and you can hack your way around building your class in such ways. And that, I mean, the beauty of it is that you can make it as simple or as complex as you want it. I mean, processors are still Java code, so you can make it as you want. It doesn't have like a set of rules over here. Right now, we're making it this quite simple. As you can see, we're hacking our way around it, just so we don't build any unnecessary code or non-valuable code to us. So once that's out of the way, I want to present to you the two test subjects, which is fake class happy path, which is a happy path for us for a builder because it doesn't have a constructor. So by let's say by default, the Java is going to provide us with an empty with a public with no parameters constructor. And over here we have a default constructor. Well, we don't have a default constructor, and also the constructor does not consider all the attributes of the class. So the way that we are going to build the actual code itself, no, sorry, I don't want to use the terminal. So it's by just like any other Maven package. You need to just run Maven clean install. Clean is just to remove the previous files that you created, and install is just to trigger all the lifecycle. So in that way, you are going to trigger also the lifecycle of the compile lifecycle, and on that by doing so, you're going to execute to build your own classes. So right now we have these two, the fake class happy path, which is these two are the results of these two classes that were previously annotated. But just so it's quite clear, we're going to run it live. So clean, so that Maven deletes these classes, and you can see by yourself that we are generating the actual results. So right now it's now running the test. So we have a build success. And over here, if we open it, we can see that this is our generated class. And okay, as you can see, it's going to throw an error right now because it's not correctly linked in our project structure, but the class should work by itself. No need to worry over there. This is the class that we generated ourselves. And wait, close that. Okay, this is the other class that we generated when we don't have a default constructor. So as you can see, we are going to obtain like the least parameter constructor, and then afterwards we just need to populate whatever fields are missing. So those are working just fine. Now I want to demonstrate the actual benefits by doing another demonstration of how to implement the code that we show right now in an actual project. So this is another project, and as you can see, it's called Reflective Builder. Let's take a look really quickly to our POM file. Over here, I mean, just a really standard Maven architecture. However, the only sole difference that we do have over here is that we are having the dependency of our previous project just to make use of the annotations and the actual files that we are going to generate. So the way that this project works is it's just an actual demonstration of how the builder annotation is going to be faster than our equivalent reflective one. So if you can see over here, we have two classes, and we are timing how much time it takes to insert each of them. So we have the doc class, which if we review that, we're going to see that doc class is just a simple class with these 4 attributes. And basically, what the only thing that's different from this class is that it has a static class that extends from the reflective builder, which is also a class that we built just to centralize all the common logic for building a class using a reflective pattern. So basically over here we are obtaining the class that we want to analyze. We're obtaining the setters, the attributes, and we're doing the mapping ourselves. However, we do need to state that this analyzed part is going to be done on runtime, so that's why it's going to take a little bit longer. Well, quite a lot actually, and also because the reflection API it's just slower overall, and it shouldn't actually be used but in performance sensitive applications. So yeah, basically that's that. It doesn't really do much, as you can see in the actual implementation of the doc builder. We just set values, and since we're making use of a map, so we can we need to pass like the name of the field, and we need to know the name of the field that we are going to set. And if that's incorrect by whatever reason, that's going to be an issue, because it's not going to find the actual setter for that field. So as you can see, it's quite sensitive to, it's error prone, and it may not be like the best solution after all, but it's a way that you can do that. On contrast, we have the Swan class, which is the same class actually, well, only different name, but same attributes, same everything, except that it's using the add builder annotation we created. So if you see over here, we have the import for the annotation of the other project, which is the builder. And again, it's same class, same setters, same getters, same everything. So now what we are going to review right now we already generated the class, but we are also going to do it right now. Okay, so we have this is the generated class, and the benefit of using the Swan builder as opposed to the builder, the reflective builder, is that you have type integration built right out of the box. So you're going to have, for example, set name, and it's going to know to receive only strings. For example, set cities flown to. If we see sorry, this is not the class. It's this. So if we see the Swan, where is Swan? So here's Swan. So the cities flown to, it's a list of strings. Also, order is not important, so you can do whatever order of calls you want. So set cities flown to, set if it knows how to fly, the number of feathers it has, and basically just a call to build, which is going to return us the actual instance of Swan. And again, we'll just have like the timing of each instantiation, just for simplicity's sake. So, sorry, again, wrong. So we're just going to clean install it, just so you can see that we're going to generate the Swan builder again. Okay, so we got success, no problems over there. And now we need to run the class. Just run main, just so you can see the actual difference in performance. Right now, as a side note, I'm plugged into the AC current, so times are going to be much faster as opposed as if I was unplugged. So, but we do have a significant difference over here, 10 times actually, somewhat more than 10 times. But yeah, I mean, the doc instance that was built using reflection took 39 milliseconds, whereas the Swan took only 3 milliseconds. So that's a significant performance boost over using reflection. Again, It's not that I hate reflection, but it's not meant to be used on performance-sensitive applications. So just have that in mind, that it does have its benefits of using this one. Now, as promised, I was going to talk to you about Project Lombok. So Project Lombok is quite a controversial project for the annotation processing world, because it makes use of some, and the best way to describe it is hacky maneuvers to actually make to actually modify an existing class, as you could saw in the simple annotation project. We were creating new files as opposed as modifying existing ones, and that's because that's like the intended behavior for Java, to create, not to modify. So that's the way that they do that. Unfortunately, they do have like some hacky behaviors. If you check out the GitHub repository, well, for the Lombok, you're going to see that even in the discussions, they mentioned that if the approach that they are using, if it's correct, some enterprises do have like a security concern of using Project Lombok. So if that is your particular use case, that you are not able to use Project Lombok, don't worry. For most of the use cases of Project Lombok, you can make your own annotation and make the code yourself without having to modify the actual class. And in that way, you can also, the way that you're going to solve it, as opposed to Project Lombok, is by making use of the hierarchy of the Java classes hierarchy. So, for example, if you want to override a class that you built by adding, I don't know, a setter or a getter, you should make a class that extends from your base class, which adds these new methods. So that's the way that you're going to handle all of it. But I mean, I understand that it's quite convenient. Project Lombok is quite convenient, but again, it's not like the silver bullet that we hoped it for be. So that's about it for my demonstration. Let's move on to questions. Does anyone else? Well, let's move on to the Q&A session. So just let me fetch over here yeah, thanks.
Hello again. So Oscar, it was amazing. It was very interesting and very technical. I believe guys who was not aware about annotations now learn it and be ready for example interview questions or improve project. I like your way how you show that that performance can be increased. Cool. Okay, so we don't have a lot of questions so far in chat. Let me double check. Here, and in the Discord. I guess you showed a very clear topic, and our colleagues have no questions here. But I have one question for our colleagues.
Before you proceed with questions, we have first of all the comment that annotations are a lifesaver, and it helps us reduce much of the boilerplate code which we may have. And also we have a comment that it was a great talk. So Oscar, thank you very much.
Thanks, Roma.
Yeah, thanks. And so, from my side so far, a question to our auditory who watch us. Well, Oscar, I saw that you are using IntelliJ IDEA and night mode. Just Holivar, colleagues, who of you, which mode are you using? Why day mode, light mode, or night mode? My project is like Holivar sometimes. So while we waiting answers, Oscar, second questions to you from my side. What you can suggest to person who first time in life will start writing his own annotation? Just suggestions, couple of suggestions from your experience.
Yeah, my suggestion is to try to keep it simple. Try to keep it independent of what you want to do and reusable. That's like the main point of of making a good annotation. Make it as reusable as possible and make it as independent as possible.
Good suggestion. Thank you. So we have a question from Anton Lukyanov. How was created annotations which are used for creating custom annotations?
Okay, so basically you want to have an annotation to create a custom annotation. That's what I am understanding. The same way. So basically, let me reshare my screen. Okay, so as you can saw in the Java class writer, we are creating a source file. The source file, how JavaX understands source files is just any old .java file. So in that sense, you can create your own annotation for building your own annotations. I mean, quite a retrospective way of doing things, but yeah, I mean, that's possible. There's like no side effect, no problems of doing so. What I think you shouldn't do is to build your own annotations, well, your own processors based on code generation. Not because you're not able to do so, but it's not like an operation that you want to automate so heavily, because it does have some tricky bugs down the line. Mainly trying to know what you are mapping, especially in the JavaX element side of things. So yeah, I mean, it's completely possible. I'm not against it, but you should tread carefully. That's like
I totally agree. Cool. So I believe it fully answered. No more other questions, and we see answers on the first hour question. Most of modes I see, it's a dark mode, night mode. So light mode is not so popular in nowadays. Roman, and which one you are using mode?
Black one. Dark mode and theme dark.
Dark mode on. And our Java one today is in dark mode.
Yeah, exactly. So I suppose saying that, I want to thank you, Oscar, again for your great talk. It was just awesome. So thank you very much for being here with us and share your experience.